Hello, this is Charlene. In this video, we're going to be talking about annuities, methods of saving, and investments. But before we jump right into annuities, I want to talk about something that we previously talked about and the formulas that we used. We had compounding interest savings accounts, and we used these two formulas, this formula and this formula. The A stands for the amount of money that you're going to accumulate in the future. The P in this formula represented the present principal amount, and it also was a lump sum. There was a big pile of money that you were going to put into this account and kind of leave it there for a period of time in order to earn interest. But now that we're going to be talking about annuities, that P is going to mean something different. This A and this A still mean the same thing. How much money are you going to accumulate in the future? But this P right here is completely different from this. This P is now going to represent a regular payment or deposit needed to achieve the financial goal. To reiterate, this was a lump sum when we were talking about compounding interest savings. That was a lump sum, a one-time pile of money that you were going to put into the savings account or whatever the investment account was. With annuities, you are not going to put in a one-time lump sum. You are going to make regular payments or deposit into an account in order to save up and achieve a financial goal. You will be receiving interest on that, but you're not going to start out with one big lump sum. You will be making regular payments and deposits in order to accumulate this future amount. So the formulas look completely different. So this formula does not look like that formula, even though it is the accumulated amount for an annuity. And this formula obviously does not look like that
formula.
So you need to understand that this P right here, is not the same as that P up here. Okay, the first problem in the annuity section that we're going to work on says that we're going to find the value of each annuity and we will round to the nearest dollar. So what do they mean by find the value of the annuity? Well, it's talking about this accumulated future value. What is the value going to become in the future? What is its final and total accumulation? So that means that we are going to use the A formula. We're going to use this formula right down here for the accumulated future amount. The value of the annuity in the future is the A formula. Okay, so we're also going to have a periodic deposit of $3,000. We are going to have a rate of 4%, and we're going to have a time period of 20 years. So this other information says at the end of each year, and compounded annually. That means the same thing. At the end of each year, it means one time. Compounded annually means one time. So that means that by N, my compounding period N is going to be equal to 1. So the compounding period will go in the N position of our formula. And the 3,000, that is my not lump sum. I'm going to be making regular payments every single year of 3,000. I'm not just going to put it in one time at the beginning. I'm going to do 3,000 and 3,000 and 3,000 for the entire 20-year period. And that means that the T number will be the 20. So the T will be 20. And of course, my rate is going to be 4%. So the rate will go in the rate position. And of course, just always remember that we do not use percents. We always convert them to their decimal version. So if we want to convert 4% to a decimal, I would divide the 4 by 100, and it would automatically convert it to 0.04. So that's the decimal that we will actually use in our formula. Okay, so let's go ahead and put everything into the formula. My A, my accumulated future value of the annuity, is going to be equal to my periodic deposit or my payment amount every year, which is going to be $3,000. So $3,000 is my payment amount or my deposit amount. I'm going to multiply that. And also just note that this is a bracket and a parentheses, but I can just put parentheses. They are treated the same way. So in my calculator, I don't have to find the bracket. I could just use two parentheses. Okay, so parentheses, and then 1 plus my rate of 0.04 divided by my compounding period. We determined that the compounding period was 1 time a year. So 1. I'm going to close my parentheses, and then I'm going to raise it to the compounding period times the time. Compounding period of 1 times the time of 20 years. So that's 20. But don't forget to do minus 1 over here. If you don't put the minus 1, it will not give you the correct answer. So minus 1, and then close your parentheses. And anytime you do have parentheses or brackets, you should have a matching even number. So there's a parentheses, and then the outer parentheses. So they all should line up. Okay, and then all of that is divided by the same ratio. R over N is in the numerator, R over N is in the denominator. So I'm going to repeat the 0.04 divided by 1. So 0.04 divided by 1. So now we just have to put all of that into our calculator. So let's go ahead and do that. So our graphing calculator, we can use our fraction functions, and we can make the formula look exactly like it does in our given formula. Okay, so alpha F1 gives me the option of numerator over denominator, which is the fraction function. Enter, and then 3,000, and then parentheses, 1 plus, I've got another fraction, so I can do green alpha button, green F1, gives me the option of fraction again. I'll put 0.04 in the numerator, down arrow, put a 1 in the denominator, right arrow to get out of the fraction, close the parentheses. Then up caret lets you raise up to the power position, and it's 1 times 20. 1 times 20. Now I need to get out of the power position, so I'm going to do right arrow, and don't forget the minus 1, and then close your parentheses. Okay, then I'm going to go down arrow to get into the denominator, except I have another fraction in the denominator. So I'm going to do green alpha button, green F1, choose the fraction, and then 0.04 goes to the numerator, down arrow, put a 1 in the denominator, and now get out of that. And so everything should be set up exactly the way I need it. It should look exactly like my formula here. Yep, there's my formula. And then I can just push enter, and it gives me an answer of 89,334.235. This says to round to the nearest dollar. So is the 23 big enough to change the 34 to a 35? No, I'm just going to leave it at 89,334. So that accumulated amount is going to be equal to 89,334. If you don't have a TI-84, you can always work the equation a piece at a time. You would start by doing what is inside the innermost parentheses. So that means we would calculate this part. The second step would be to raise it to this power. The third step would be to subtract the 1. Once you've done that, that will give you the value that's inside the outermost parentheses. The next step would be to multiply that by 3,000. At that point, we would have a value for the numerator, and then the final step would be to divide it by this denominator. So let's work through that on our calculator together. So we're going to do 1 plus parentheses 0.04 divided by 1 parentheses. Putting parentheses around that fraction tells the calculator to treat it as a fraction. Okay, then I push enter. I get a value. I'm now going to raise it to 1 times 20. 1 times 20 is 20. So the up caret button on your calculator will raise it to a power of 20. And I get a value there of 2.1911, etc. Now I'm going to do the next step, which is to subtract the 1. And that gives me a value of 1.1911. That gives me the value that is inside the outer set of parentheses. Now I'm going to multiply times 3,000. So times 3,000. That gives me 3,573 and some decimal places. So the final step is to divide by the 0.04 divided by 1. 0.04 divided by 1 is just 0.04. So I'm going to divide that by 0.04. And it does give me the same exact answer that we should have, 89,334. So $89,334. That is going to be the value of the annuity at the end of 20 years. Part B wants us to find the interest of our annuity. So how are we going to go about that? Well, we could find the interest by looking at the accumulated value and subtracting the sum of all my payments. Well, we know from Part A that our accumulated value is the $89,334. That's the accumulated value of our 20-year annuity. Well, how do we find the sum of all the payments? Well, the sum of all the payments can be found using this P times N times T. So that is how we would find it. Now, what do those stand for? Let's remind ourselves. The P stands for the deposit amount. Well, how much were we depositing on a regular basis in the annuity in Part A? I was depositing $3,000. And how often was I depositing $3,000 every year? Well, I was only depositing it annually, one time per year. And for how many years were we depositing it? Well, we were depositing the $3,000 at the end of every year for 20 years. So when I calculate those together, that will give me the sum of all of my payments. So 3,000 times 1 times 20 is 60,000. So that means now I have the sum of all my payments is equal to 60,000. So that means up here I can say my accumulated value minus the sum of all my payments is 89,334 minus 60,000. 60,000 is what I deposited over the course of the 20 years, and that gives me a total of $29,334 in interest. So over the course of 20 years, my annuity earned $29,334 in interest. The next problem says that at age 25, to save for retirement, you're going to deposit $75 at the end of each month in an IRA. This IRA pays 6.5% and it is compounded monthly. And they are asking us the question, how much will you have in the IRA when you retire at age 65? So they've given us a beginning age and an ending age, and from that we can determine the time. The time is going to start at age 25 and go to 65. So if we subtract 65 minus the 25, that gives us a time of 40 years. We're going to put into our retirement IRA for 40 years. It also tells us that the interest rate is 6.5. So that is going to go into the interest rate position. Interest rate right there. Our time is 40. The time will go here. And then it says it is compounded monthly. So that means that it is going to be how many times per year? The N number is going to be N equal to 12. 12 times per year is monthly. Okay, and then we also have our periodic regular payment is $75. So that is my P number. My P. Remember, P stands for the regular deposits or regular payments when you're talking about annuities. So that means that number, 75, will go in the P position. So it looks like we have everything accounted for in our equation, and we're just going to fill everything in. So when we do that, we will end up with all of these numbers here. Our regular monthly payment is $75. Our interest rate is the 0.065, 0.065. Our number of compounding periods is monthly. That's 12, 12, and 12. And our time is going to be the 40 years. So we put all that into our calculator. It will calculate for us if we're using the TI-84, and that means that after 40 years, we are going to have this number. We are going to have $171,271 in our retirement account. Part B wants us to find the interest on our IRA. So again, we look back to the formula for that. The interest is equal to the accumulated value minus the sum of all my payments. Well, we determined in Part A that the accumulated value of our annuity, our IRA, was 171,271. So we are going to have to calculate the sum of all my payments. The sum of all my payments can be summarized as the P times the N times the T. And if we remind ourselves that the P is the deposit amount, and the deposit amount was $75. And how many times a year? I was doing it monthly, so it was times 12 times per year. And for how many years did I deposit $75 a month? Well, it was for 40 years. And when I calculate all that, that is going to give me the sum of all of my payments over those 40 years was 36,000. So that means that I can subtract 36,000 is the sum of all my payments. And that means that my interest that my IRA accumulated over the course of those 40 years is 135,271 in interest. Our next problem says to offer scholarships to children of employees, a company invests $15,000 at the end of every 3 months in an annuity. This annuity pays 9% compounded quarterly interest. They want to know how much will the company have in the scholarship fund at the end of 10 years. So again, we always have to find all the information for our formula. So our P is the regular periodic payments. Well, what kind of payment were they making? They were making a $15,000 payment or investment. Okay, so let's do $15,000 as our P. And they said that they're going to do it at the end of 3 months. So every 3 months. So how often is every 3 months? And here it also, this is a clue also. Every 3 months also means quarterly. So quarterly means 4 times a year. So my N number is going to be 4. Then it says that it was going to pay a 9% interest rate. I don't use the percent. I change it to a decimal. 9 divided by 100 gives me 0.09 as my interest rate that I will use in the formula. And my T is at the end of 10 years. So T equals 10. So I'm going to put all those numbers into my equation. So it's going to be equal to 15,000. And that's going to be multiplied times 1 plus the rate of 0.09 divided by the number of compounding periods, which is 4 times a year. Close that parentheses. I'm going to raise it to the 4 compounding periods per year times the time, which is going to be 10 years. Then I'm going to subtract 1 and I'm going to close my parentheses. All of that will be divided by the same ratio that was in the numerator, the 0.09 divided by the 4. And when I put all of that into my calculator, it is going to give me a scholarship fund of $956,792. So I'm going to round that up. 64, I'm going to round that up to $956,700. Part B wants us to find the interest that accrued on the scholarship fund. We find the interest by taking the accumulated value and subtracting the sum of all of the payments. We determine in Part A that the accumulated value of the scholarship fund was $956,793. We are going to find the sum of all of our payments by multiplying the P times the N times the T. And again, we can remember that the P is the deposit amount. Well, the college deposited $15,000 and they did this on a quarterly basis. So 15,000, 15, that's a comma right there, times 4 times a year quarterly. And they did this for 10 years. And when we multiply that, that gives us a total payments made to the scholarship fund of 600,000. So that means I can take the 600,000, which is the sum of all of my payments, and I can subtract that from my accumulated value. And that gives me total interest that accumulated on the scholarship fund over the 10 years is 356,700. Okay, this problem says determine the periodic deposit. Round up to the nearest dollar. Periodic deposit is the dollar amount at the end of the year, paid at the end of the year. The rate is going to be 5% compounded annually. The time is going to be 18 years, and the financial goal is going to be 150,000. So what we need to notice in this problem, how it is different from the one previously, we were previously looking for the accumulated value of the annuity. In this one, we are not finding the accumulated value. We are finding the periodic deposit. So that means that we are going to use the P formula. That also means that we are no longer are given the regular payment amount. We are given the goal. So we are given the A value. The A value represents the accumulated value of the annuity. And in this one, it tells us that our financial goal is 150. So 150,000 is what we want the accumulated value of our annuity to be in the future. Our financial goal is the A number. So let's go ahead and plug that in. The A, the accumulated value that we want in the future, is going to be the 150,000. Okay, and the N number, that's the number of compounding periods. So it says that it is compounded annually, and that is also reiterated where it says you're going to pay some amount at the end of each year. So at the end of each year means one time, and compounded annually means one time. So that means that my N is going to be one time per year. I'm going to make a payment on my annuity only one time a year, and it's going to compound annually, which means one time a year. Okay, we also need to find our rate. Well, it tells us that our rate is a 5% interest rate. So we're going to put that here, but we're going to convert it to a decimal. We'll divide that 5 by 100, and it will give me 0.05 as the interest rate that we will enter into our formula. Now we need to find our time. Well, our time is going to be 18 years. So we're wanting to save in 18 years, we want to save 150,000, but T is going to be 18. So now that we have confirmed that we know all the information that needs to go into our formula, we're going to put those numbers into our formula. Okay, so the P, which is our payment that we're looking for, is going to be equal to the A, which is our accumulated value that we want in the future. Our financial goal is going to be 150,000. So 150,000. And we are going to multiply that times the rate divided by the compounding periods. So the rate is 0.05. 0.05, and that's divided by 1 compounding period per year. Okay, and then that is in the numerator. Our denominator, again, I said that that's a bracket and a parentheses, but for our purposes, we can just do two parentheses. We could put two parentheses into our calculator. So that is 1 plus, again, the same ratio, 0.05 divided by the compounding periods of 1 time per year. Close that parentheses. We're going to raise it to the compounding periods of 1 again, times the number of years. Well, it's times 18 years. And then we're going to subtract 1, and then we will close our parentheses. Okay, so that's how we're going to put it into our calculator. If I put that into my TI-84 calculator, it is going to give me a payment, an annual payment of this number, and it says that it wants us to round it up to the nearest dollar. So that means that my payment that I'm going to make once a year on this annuity is going to be $5,332 per year. Okay, part B says how much of the financial goal comes from deposits and how much comes from interest. So let's calculate our interest. We can say interest is equal to accumulated total minus all my deposits. Another way to think about this is interest is equal to the financial goal. So we got to understand that our accumulated total is the same thing as our financial goal. It's like, what is the value of that annuity at the end of the time period? And my deposits that I'm making, my periodic deposits, are the same thing as my payments. So you can use any of these words interchangeably. So what was my financial goal? My financial goal was $150,000, right? $150,000. And we need to calculate what all of my payments added up to. So how do I do that? Well, before in our previous problem, we said the sum of all of our payments can be thought of as P times N times T. And in part A, we actually did calculate the P, right? Figured out what the deposit amount was. The P is the deposit amount, the N is the how many times of year are we making the payment or how often is it compounding, and the T is for how many years. Well, in part A, we did figure out that our deposit or our regular payment amount was $5,332, and we're going to multiply that times how many years? Well, how many times a year? It was annually. That means it was only 1 time per year. And then we did that for how many years? We did that for 18 years. So when we put that into our calculator, that gives us a total payments. The sum of all of our payments is going to be 95,976. So that's where we can plug this into my interest formula. Interest is equal to the financial goal minus all the payments. The payments are $95,976. And that means that my interest is going to be equal to the difference between those two numbers, And the difference between those two numbers is going to be $54,024. $54,024. So when I make all these payments, $5,332 once a year for 18 years, my annuity is going to pay me $54,024 in interest. The next problem says you would like to have $4,000 in 4 years for a special vacation following graduation by making deposits at the end of every 6 months in an annuity. This annuity pays 7% compounded semi-annually. How much should you deposit at the end of every 6 months? And they also want us to round our final answer up to the nearest dollar. Okay, so again, we need to find the deposit amounts. Now, how much should you deposit? The deposits are going to be your regular payments. Your regular payments. You also can call those periodic deposits. So regular payments, periodic deposits means that we are going to use the P formula. That is for annuities, that P stands for the periodic payments or deposits that we are going to make on our annuity. So the things that we need to find are the A, which stands for how much is our goal? What's our goal? What do we want the accumulated amount to be at the end? And what is the number of compounding periods? What is the rate? And what is the time? Well, we should be able to find all that in the information that they've given us. They say that our A is our goal. That's our accumulated amount. Our goal is to have $4,000 in 4 years. So $4,000 is the A number. And in 4 years. So 4 years, that's going to be our T number. So T is going to be 4 years. Then our N is our compounding periods, and it says it is compounded semi-annually. Semi-annually means 2 times per year. And our rate is going to be the 7%. And of course, we will use the decimal version of that. So 7 divided by 100 equals 0.07. Now we should have everything that we need to put into our formula. So let's go ahead and list everything in our formula. The A number is 4,000, so $4,000 is the goal. That's what we want our final annuity value to be. Rate is 0.07. Our number of compounding periods is how many times are we going to make this payment. We're going to make it twice a year, semi-annually, so 2 times per year. And that is the numerator, denominator, parentheses, parentheses. You can use brackets if you want to, but I just tend to put everything in terms of parentheses. So 1 plus the ratio again of 0.07 divided by 2, so 0.07 divided by 2 times per year. We're going to make our payment. Close that parentheses, raise it to the twice a year. We're going to make payments and times the number of years, which is going to be 4. Then I'm going to subtract 1 and then close my parentheses. So this is how I'll set up my problem. And like I said before, earlier in the video, you can do a piece at a time. We could do the innermost parentheses here. Then we could raise it to a power, and then we could subtract our 1. That would be my denominator number. And then I could also, in the numerator, I could do my ratio and then multiply my ratio times the 4,000 and get a number and calculate all those pieces one at a time, as long as I do them properly. And the main thing I want you to know is that you need to start in the innermost part of the parentheses. You'll work your way out from inside the parentheses if you are working your problem one piece at a time. If you're putting it into your TI-84 calculator, you can use the fraction functions and it will give you your deposit amount. So it says our deposit amount is going to be this number, and it says to round it up to the nearest dollar. So that means that my deposit amount every 6 months is going to be $442. Part B says how much of the 4,000 comes from deposits and how much comes from interest. Well, how do we calculate the total of the deposits? The deposits are the same thing as the payments that we're making. And we find the sum of all the payments by P times N times T, where P stands for the amount of the payment or the deposit that we're going to regularly make into the annuity. So 442 is what we found in Part A was the amount of the payment. The number of compounding periods which is also equal to the number of payments we make per year for this problem is going to be 2 times per year because it said semi-annually. And then the time was 4 years. So $442 payments times 2 times per year times 4 years. And that's going to give me, when I put that in my calculator, a number of $3,536. So how much comes from the deposits? $3,536. Now, how much of that is going to come from the interest? Well, again, how do I find the interest? The interest amount is equal to my total financial goal minus all my payments. We can also think of this as the accumulated total. So this is the same thing. My financial goal, where I want to end up, the total value is the same thing as the accumulated total. And all my payments, again, is also the same thing as all my deposits. Well, I know now what all my deposits are. All my deposits are the 36, and my accumulated total originally was to save the $4,000. So that's going to be $4,000 minus the 3536. And when I put that into my calculator, it is going to give me a value of interest, a total value of interest is going to be $464. Okay, this problem says how much should you deposit at the end of each month into an IRA that pays 8.5% compounded monthly to have $4 million when you retire in 45 years? And then we're also reminded to round to the nearest dollar. Okay, we need to make sure that we understand that the deposit, how much should you deposit, is the same thing as the payment amount. The payment that you're going to make on a regular basis, your periodic deposit, and that reminds us that we are going to use the P formula. Okay, we also need to find all of these pieces and parts that go into that formula. The A number. The A number is how much do you want to accumulate? How much money do you want to have at the end of this time period? Well, it says that we want to have $4 million. So we're going to write $4 million in here for our A number. And then we also need to find our N number, which is the number of compounding periods. It says compounding monthly. It's also how often are we going to make the payments. The compounding number and how often we're going to make our payments is the same thing. And how many months are in a year? Well, there are 12 months in a year. The R, it stands for the rate. We have an 8.5% interest rate. We're going to divide that by 100. It's going to give me 0.085. That's the number, the decimal number we will use in our formula. And the T stands for the time. And we're going to be putting money in this account for 45 years. 45 years. So now we're going to take all these values and put them into our formula. We're going to take the $4 million. That is my A number. And we are going to put it over here. Okay, and then we are going to multiply that by the ratio, the 0.085 divided by the number of compounding periods, or how many payments we're going to make every year, and it's 12. And that's my numerator. My denominator, I'm going to have parentheses, 1, plus the same ratio that's in the numerator, 0.085, divided by the compounding periods or the number of payments we're going to make every year. And we're going to close that parentheses. We're going to raise it to the compounding periods of 12. We're going to multiply that times the time, which is 45 years. And then we are going to subtract 1 and close our parentheses. The parentheses are very important because if you're putting it into a TI-84, if you do not properly put in your parentheses, your calculator cannot read your equation properly. Okay, we are going to first work this out like we would on a calculator that is not a TI-84 to remind us what we need to do if we're not using a TI-84. So the first thing that we are going to do is work on this numerator. We're going to calculate the numerator on our calculator first. Okay, so that's going to be 4 million. And then I am going to do, okay, I'm going to multiply that times the ratio or fraction of 0.085 divided by 12. I'm going to put that in parentheses to make sure that my calculator understands that that is a fraction and it needs to be treated as a fraction. Okay, so that gives me this value, 28,333.333. And we need to understand that when we're doing a regular calculator and doing it a piece at a time, we need to keep all these decimal places because if we do not keep these decimal places, our final answer will be off. So there's my numerator. And now the next part that I'm going to work on is going to be what's inside the parentheses here in the denominator. So let's go find our calculator. We're going to do that piece inside the parentheses. So it's 1 plus, again, the fraction, the ratio, needs to be put in parentheses to make sure that your calculator understands that it is a fraction. If you do not put parentheses around it, it will probably add the 1 to the 0.085 and then divide 1.085 by 12, and that will be incorrect. So you need to make sure you put your fraction inside parentheses so that it reads that ratio as a fraction that's being added to 1. Okay, so 1.0708333. So that means that I'm going to bring this over here. This is now the value that is in the parentheses. So I got parentheses here, but I need to raise it to this power, the power of 12 times 45. So calculator time again. Okay, 12 times 45 gives me 540. So that is my power that goes there. And of course, I will still be subtracting all of this from 1. Or, yeah, subtracting 1 from all of this. Okay, and then that is in parentheses as well. Okay, so now the next part that I'm going to do, a piece at a time, is going to do this number raised to the power. Okay, so calculator, I'm going to go get that number, put that into whole number with all the decimal places, and I'm going to raise it up caret to the 540. And that's going to give me this number 45.218, again, with a lot of decimal places, but we need to keep it. So at this point, I have this. Oops. This is what we have. We have this is equal to, there's my numerator, there's what's in parentheses raised to a power, still minus 1. So the final calculation would be subtracting 1 from that. And when I subtract 1 from that, well, that's going to give me 44. So this, I will end up with these two numbers in the numerator and denominator. So equals, and now the final calculation is to divide those two numbers. Okay, so I'm going to take the 28,333 number with all the decimal places, and I'm going to divide it by the 44.218965505, and it's going to give me a final answer of the 640.75. And if I round that up to the nearest dollar, that means that how much should my deposit be, my regular payment should be? It should be $641. Okay. So, like I said, you can do this a piece at a time, or you can put it into your graphing calculator and it'll do all these calculations for you. Our final question says, how much of the $4 million comes from deposits and how much comes from interest? Well, all of my deposits are the same thing as all of my payments, and I can find the sum of all my payments by P times N times T, where P stands for the payment amount. Well, we just figured out in part A that the payment amount was 641. So the N is the compounding periods, or how many times we made a payment every year. Well, we made the payment every month, so 12 times a year. And the number of years that we made the payments was for 45 years. So when I calculate that, that gives me a total sum of all my deposits is going to be equal to 300 and $46,140. So that is how much comes from all my deposits is that figure right there. Okay, now we want to figure out what is the interest. Well, we figure the interest by saying what is the financial goal minus all of my payments, or what is the accumulated total minus all of my deposits. And the accumulated amount was the $4 million. So we can do our financial goal was $4 million. That's what we ended up with after we made all those payments for 45 years. And then we just calculated my deposits right here. So all my deposits added up to $346,140. And when we subtract those two things, that will give us our interest. So our interest is going to be equal to 3,653,860. So lots of payments over lots of time earns you lots of interest. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.